All right, this is Algebra lesson 8.2, using the distributive property. Okay, what if I was to say this to you? I have 27y squared plus 8, and 18y. And I was to ask you to tell me what is the greatest common factor of those two. Could you do it? Could you tell me the greatest common factor of those two? What is it? It's 9y, right? You look at the numbers. What's the biggest number that goes into both? 9. Then you look at the variables. What's the biggest variable that goes into both? Y. So you'd say it's 9y. Agreed? So yesterday's assignment set you up for what was going to happen today. I know you watched this 2 days ago with Mr. Khan. So I'm going to show you. Here's the question. If I have 27y squared plus 18y, actually I'll just leave it like that. And I said, I want you to factor this. I would say I want you to factor it. To factor something means to break it into smaller parts, right? Or break it into its smallest parts. What you're looking for here is you're looking for, what can I pull out of this thing? What can I pull out of this thing? Well, we already decided that the greatest common factor of those two monomials is 9y. So I'm going to pull out 9y. This is what you do. You literally write down 9y here and put in parentheses like that. And then you go up here and I only have this a few times, but you divide it by 9y. What is 27y squared divided by 9y? 3y. What is 18y divided by 9y? Plus 2. And we're done. Okay, that's all there is to it. We're doing the exact same thing we did before. We're finding the greatest common factor, but now we're just using the distributive property in reverse, right? We're undoing it by dividing by the greatest common factor to come up with this. How do I know if we got it right? What can I do to make sure I got it right? Use the distributive property. What is 9y times 3y? 27y squared. What is 9y times 2? 18y. Does that make sense? That's how you do it. Let me give you one. Negative 4a squared b minus 8ab squared plus 2ab. Try it for me. Seriously, you're watching now. I have, what is this thing called, by the way? That's a trinomial. You see it? It's a trinomial. There's 3 monomials. There's 3 terms there. Right? There's 1, 2, 3 terms. In this trinomial, if I was to tell you, I want you to factor this. That's the word. I want you to factor it. I'm going to break it down into something smaller. That means, what can you pull out of all 3 of them? Okay, so you look at the numbers. I have negative 4, I have negative 8, and I have 2. What can I pull out of all of them? I can pull out a 2, right? I'm going to pull out a 2. What's the biggest amount of A's that is in each one? There's an A, right? And then what's the biggest amount of B's that is in each one? There's a B, right? And that's it. Agreed? That's what I can pull out. So then you go parentheses, parentheses, and you're going to go, listen, on each one of these, I'm going to go 2AB. Each one, but okay, I don't need to do that. I can just go 2AB, right? And each one of these, what is negative 4a squared b divided by 2ab? Well, it comes out to, what do you think? Negative 2 and then a. Okay, that's done. And then what about negative 8 over this? This would be minus 4b, right? And then what is 2ab over 2ab? This is a very important concept. A lot of the times, what do we do when we see something like this? We just cross them out, right? Is that what we do here? Just cross them out? What is 2ab over 2ab? It's 1. It's plus 1. Does that make sense? It's a plus 1. If you aren't sure what to do here, if you aren't sure you got it, what can you do? Distributive property, make sure you got it right. Does that make sense? How many of you have 2ab times that thing? Does it make sense? Does it make sense? Okay. We'll do one more really short and simple one. We'll do this. We'll do this. 7u squared t squared plus 21ut squared minus ut. Do that one. Should give you about 1 minute to do it. Oh, You're just looking at this. First of all, you have to recognize things. What is that thing? That's a trinomial. Okay, so that means you're going to have a trinomial inside the parentheses when we're done, right? Okay, what can I pull out of everything here? What's the biggest number I can pull out of all of it? Just a 1. That's the biggest number, as in numerals, right? There's no number here, so I can't pull out any numbers, right? So that thing's gone. There's no numbers. What's the biggest amount of u's I can pull out? There's a u. What's the biggest amount of t's? A t. That's it. So it's going to be ut times, and notice I put the parentheses out there right now. That's what I do. Then you go, okay, the whole thing's divided by ut. What is 7ut? U squared, t squared divided by ut is 7ut, right? And then here, what is 21ut squared divided by ut? Well, that would be a plus 21t. And then what is negative ut over a positive ut? Minus 1. How many of you got that? Does it make sense? Does it make sense? Okay, now I have to show you the next thing. Okay, I'm going to show you something. I have a question really quick. I just want to show you this. What is 2x plus 3x? What is that? 5x, right? So what if I was to write it like this, though? What if I was to write it like 2 times x plus 3 times x? What is 2x? What is 2 times x plus 3 times x? 5 times x, right? Do you understand that? You see that? And that shouldn't, me writing it to you in this method should not bother you. Make sense? You all know that's 5x, okay? Okay, every once in a while you're going to get a problem like this, and this is when things start to get interesting. This is the beginning of a very interesting, 4qr plus 8r plus 3q plus 6. Okay, I'm going to show you this. I want you to look at this and tell me what, first of all, what this is this a trinomial? No, there's 4 terms there, right? This is ugly. Okay, what can I pull out of all of those? What can I, if I say to factor this, what can I pull out of these babies? That's it, right? So if all I can pull out is 1, then I'm not pulling anything out. Do you agree? Then you would say this is factored as far as I can go. The problem is that it's not. This is not factored as far as we can go. We're going to do what's called grouping. Okay, we're going to do what is called grouping. We are going to literally group this. We're going to group these guys like that. Okay. What can I pull out of these two now? What can I now pull out of just those two? I can pull out a 4r. Do you agree? I'm going to pull out a 4r. And what's that leave me with when I divide this by 4r? Q plus 2. Do you agree? Q plus 2. What can I pull out of 3q plus 6? So plus 3. When I divide that by 3, what's that leave me with? Do you remember when I had this? What did you say it was? It's 7x, right? So that shouldn't be a problem. Notice this. You know what this really is? So we're dealing with this right here, 4r. This is what you do. We're going to actually factor out for something from here. What can I factor out of this thing? I can factor out q plus 2. Do you see what I'm saying? I'm going to pull out the q plus 2 from both of those. Just like if it was, 7x squared plus 14x. What am I going to pull out of those things? What am I pulling out of this? Right? I'm going to pull out what is common here. I'm going to pull out q plus 2. So I'm going to go q plus 2, pulling that out, right? And that leaves me with, what does that leave me left with? 4r plus 3. Now, how do you know if you got that right? FOIL. Use the distributive property. What is q times 4r? 4qr. Oops. 4qr. What is q times 3? Plus 3q. What is 2 times 4r? Plus 8r. What is 2 times 3? Plus 6. Does that look familiar at all? Does that thing... Ooh, did we make a mistake? Oh, it's plus 6 there. I just didn't write it. Does that look familiar to what the original problem was? Right? In a little bit different order, but it's the same thing. I'm going to show you another one. I'm going to show it to you again because these are a little bit, you know. Okay, what about this? What is R? I'm going to show this one to you. This one's a little bit different. You're watching. Notice this. What can I pull out of all of those? Is there any number I can pull out of any of those? No. Is there any letter, any variable I can pull out? Just of the regular old, can I pull anything out of there? No. There's nothing, right? So I need to group them. What can I pull out of this now? I can pull out an n, right? So it's going to be n times what? R plus 5. Do you agree? Okay. What can I pull out of here? This is important. What I can pull out a -1. Do you see what I'm saying? I can pull out a -1 there. Do you see it? Dividing this by -1, that leaves me with R plus 5. Now, this is important. In order for you to group properly, you know what has to be true once you're done grouping them? Is that those have to be identical, right? Because you have to pull something out. So when you group them, you know you're on the right path when these are identical. So what am I going to pull out now? I'm going to pull out an R plus 5, and that leaves me with n minus 1. Does that make sense? I know that this is a little bit stretching you, but you have to get this because this is part of your assignment. So I'm going to let you do one here in a second. Got it written down, whoever's going to? Okay, here we go. Try this one. 3np plus 15p minus 4n minus 20. Listen, this is so important. You always start out by, listen up. What if I gave you this? Hold on. Don't, stop. Eyes up here. What if I gave you this? 3x squared plus 4xy plus 8x minus x to the 5th. And the first thing you would do is you go, what can I pull out? You can pull out an x. Do you see what I'm saying? That you always start with that. What can I pull out? So when you do this one up here, the first thing you always do is you look and go, can I pull something out of there? Can you pull something out of there? Of the whole thing? No. Okay, now you go, oh, well, maybe I can group them and see if that works. Go for it. Seriously, you're watching. I'm telling you right now, you just have to follow the pattern. I mean, you just got to see what you're allowed to do. That's the whole thing about this, is you can see what you're allowed to do. Okay, the first thing you do whenever I say factor, whenever you see it in the instructions say factor, is you always, and I'm telling you this is going to come back to bite you, I promise. I promise, it's going to bug you. I mean, the first thing you always do is you see if you can pull something out. That's what you do. Can I pull something out of here? No, there's nothing that can be pulled out. And I promise you later down the road, what's going to happen is this. And let me show you what's going to happen. I'm going to end up like this. I'm going to end up with a 6np plus 30p minus 8n minus 20 or minus 40. And I'm going to say, okay, can I pull anything out of here? What can you pull out of there? A 2. And it's going to end up being 2 times this. And then you're going to go, oh, I'm done. No, because what can you do with this again? What did you just do? I can group them, right? So I'm just telling you that it starts to get ugly. You always start out with what can you pull out? Just trust me. Always start that way. Okay, nothing to pull out here. That means I'm going to start to group them. Grab these. I grab the negative. If you want, you can leave it out there. It kind of makes things confusing. I grab it. That's what I do. I grab it. I grab the sign. What can I pull out of 3np plus 15p? What can I pull out of there? What can I pull out of there? I can pull out 3p. Do you agree? Just from those two, I can pull out 3p. So I pull out 3p, divide this by 3p. What's that leave me with? N plus 5. Do you agree? Did you get that part? Okay, so do you see where that, when I do that, it leaves me with 3n, or not, that just leaves me with n, because the 3's are gone. Right? And then when I do it here, 15p divided by 3p is just 5. N plus 5. Then I go over here to this guy, And I go, okay, what can I pull out of here? What can I pull out of negative 4n minus 20? I can pull out negative 4n. Not negative 4n, negative 4. Right? I can pull out negative 4. So I pull out my negative 4, and that leaves me with n plus 5. You know you're doing this right when these two things are identical. Right? Because now at this point, am I done factoring? No. I'm going to factor it even further by doing what? Pulling out what I can. What can I pull out? I can pull out n plus 5. What's that leave me with? 3p minus 4. How many of you got that? Okay. I'll give you one more. Factor that, please. Now, for real, I just want your eyes up here. I don't want you looking at your papers. You're watching now, so you can see exactly what to do, right? You're watching. First thing you do is do what? If I say factor, what's the first thing you do? See if you can pull anything out. I'm telling you, I promise you, some of you on your test, this chapter, next chapter, you're going to forget, and then you're going to miss it because you forgot to pull out a 2 or a 3. But in this one, there's nothing to pull out. Fine, good. Since there's nothing to pull out, I'm going to try to group them. Okay, let's see what happens here. What can I pull out of here? I'm talking to Brady. What can I pull out of there? Pull out an x. I agree. So I'm going to pull out an x, right? And what does that leave me with? Brady. 2y plus 7, right? Awesome. Over here, what can I pull out of here? This is a weird one. What can I pull out of there? Is there anything to pull out? It doesn't look like there is, but what can I pull out? I could pull out a negative 1. What if they were both positive? What could I pull out of there? I could pull out a 1, right? You could. And that sometimes happens, right? But okay, this time I'm pulling out a negative 1. When I pull out my negative 1, that leaves me with what? What is negative 2y divided by negative 1? Positive 2y, right? And then negative 7 divided by negative 1 is a positive 7. Like I said, we know we've done it right when those two things are identical, right? Now that I have this ugly mess, what can I do? Can I factor it further? Yes, what can I pull out? I'm going to pull out 2y plus 7. They're gone, and that leaves me with x minus 1 times x minus 1. How many of you got that? Does it make sense? Yes. Yeah, you can do this right here and leave the negative out there. It'll still come out the same. Yep, it'll still work. You can group them any way you want to. 14 plus 2y what?
X minus 1 and 14 plus 2y. So I can reduce them.
I don't know. If you had done it the way I wanted you to the first time, you wouldn't be in this boat. But yeah, I mean, I'll show you that again. I'll show you this. Let me show you this again. So you're saying, where was the question? It was 2xy, is that it? Plus 7x minus 2y minus 7. And you're saying you did this. You went 2xy minus 2y plus 7x minus 7. You see that those two are identical. I just moved them around. I used the commutative property of addition. You see that? What can I pull out of here? X minus 1, right? And then what can I pull out of here? Plus 7 times x minus 1. So what am I pulling out now? Guess what your answer ends up being? Identical. Identical. Does that make sense? You just have to be able to group them. I mean, like they have to be groupable. You have to be able to pull something out. As long as you can pull something out, you can do this. Okay? Okay, there's something else. This is something else I need to understand. What if I have this? What if my problem ended up looking something like this? 2x times k minus 6, and then I have plus 3 times 6 minus k. You go, wait a second. Are these identical? What is 5 minus 3? What is 3 minus 5? So they're not the same at all, right? These two guys are not the same. But they look really close, right? I mean, here's the deal. You need to understand something you're allowed to do. Okay, I'm going to show you something you're allowed to do. What you're allowed to do is this. If I have 6 minus k, that is the exact same thing as negative 1 times k minus 6. And I want you to see that that's true. What is negative 1 times k? What is negative 1 times negative 6? Do you agree that this and this are the exact same thing? They're just in the wrong, different spots, right? So if you want to, it's called an additive inverse. Everybody write that word down. Additive inverse. Okay, an additive inverse. I'm going to show you what you're allowed to do again. If I have 6 minus a, and I want it to say a minus 6, you understand what I'm saying? You go, and it looks, and here's what you have, and you go, oh man, if only that was a minus 6, here's the only thing you need to do. You just need to make it, you need to go, oh, then it is negative 1 times a minus 6, and you're good. This and this are the exact same thing. They're identical. And that helps you. I'll show you one that it will help you. Okay, here, I'll show you. I'm going to show you this one. You don't have to do it. I'm going to show you one. Here it is. I have 2mk minus 12 plus 42 minus 7k. Okay, so you're just watching. I just want you to watch this time so I can show you how this works. Can I pull anything out of those? Almost. If that was an even number, then I could have pulled out a 2. I can't. It's an odd number. There's nothing to pull out. Agreed? What is 2mk minus 12? What can I pull out of there? A 2. So I'm going to pull a 2 out and make it go mk minus 6. Agreed? Okay. What can I pull out of here? Pull out a 7. That leaves me with plus 7 times 6 minus k. Did I write something wrong? Where's the m from? Oh, I wrote it wrong. Sorry. This is supposed to be an m. So then I would be pulling out a 2m. Sorry. You see what I'm saying? I'm pulling out an m. It looks like this. I need you to see it. You see what I'm talking about? Okay, so I'm really close here now. I'm really close. But oh, wait a second. Are they identical? No, they're not. They're close. In fact, you recognize, they go, oh, wait a second. These are just additive inverses. I need this to look like what? K minus 6. I need them to be switched. So what I do is I'm going to go, okay, 2m times k minus 6 plus, and now I'm going to actually, it's like I'm pulling out a negative 1 here. I'm simply going to switch the signs. If I pull out a negative 1 here, right, I pull out a negative 1, then what does that make this? That makes this 7 times negative 1, right? So I make this not a plus, it's now a minus 7. And then what is 6? What is this? What is 6 divided by negative 1? Negative 6. And what is negative k divided by negative 1? Plus k. Do you see that they're now identical? They're not in the right spots, but they're identical. Now I can do it. Do you see what I'm saying? It's almost like anytime you want to. The whole additive inverse thing, it's simply telling you that you can pull out a negative 1 anytime you want. You have to do something with that negative 1. You're pulling it out, but you can pull out a negative 1 anytime you want. So it ends up being k minus 6 times 2m minus 7. You guys try one. Remember, you can pull out a negative 1 anytime you want. C minus 2cd plus 8d minus 4. Small numbers. You should be able to do this. Standing. First thing I'm going to do is you always look and see, can I pull out something? Can I pull out anything? No. Okay, so I'm going to group them. Okay, what can I pull out of this first one? A C. So I'm going to pull out a C. That leaves me with 1 minus 2D. Agreed? Okay, what can I pull out of here? Pull out a 4. So I'm going to pull out a 4. So it's now plus 4 times, and then it would be 2D minus 1. Right? And you're, oh man, so close. See, I need you to recognize this because not every time when you're on your test, I'm going to give you these, and this is going to be in the middle of a whole bunch of different types of problems, and you're going to have to remember and go, oh man, those are close, but not the same, right? They're additive inverses. So what am I allowed to do with this if I need to? Pull out a negative 1. Or you could say use the additive inverse, right? Change this thing. So I'm going to pull out a negative 1 here. I'm going to pull out a negative 1. That means I got to literally pull it out. You're literally going to pull that thing out of there. So when I pull it out, it's going to end up being C times 1 minus 2D. And then when I pull out the negative 1, now it's going to be 4 times negative 1, which is negative 4, right? And then by pulling out the negative 1, what is 2D divided by negative 1? Minus 2D. And what is negative 1 divided by negative 1? Plus 1. And now do you see that they're identical? You see they're identical because it's negative 2D, plus 1, plus 1. You see that, right? So now you go, what can I pull out? I'll pull out a negative 2D plus 1 times C minus 4. Did anybody get that? Do you see how you can pull out a negative 1? One more then. One more. It's no good.
Because you could have multiplied the first.
No, but you wouldn't. That makes no sense. They have to. There was at no point was it a 2D. Oh, I see.
Yeah. Just 2D.
How would you know which one it is?
I don't understand. Let me look. So where did you do it?
Multiply the other one.
I understand. So then what do we come up with our answer? What was our answer finally? Okay, I'm going to. You guys have 1 minus 2D instead? Right, that's fine. It's the same thing, right? That just means you just switch those around inside, so it'd be 1 minus 2D times C minus 4. That's what you have?
No.
That's what
I got 2D minus 1. So,
Okay, let me look. Okay, so let me look.
does it matter?
I'm going to look. So when you get to this point, you pull out a C. So it goes C times 1 minus 2D, right? And then you pull out a 4 here, so that leaves you with plus 4 times 2D minus 1, okay? And so here it said you switched this guy, right?
Yeah.
Okay, so then you went, you pulled out a negative 1, so that makes this negative C, right? Negative C times negative 1 plus 2D plus 4 times 2D minus 1. It would be, you're right. They're the same thing.
Okay.
Do you see what she's saying? Because now the answer would be 2D minus 1 times negative C plus 4, or 4 minus C. Yeah, either one. Either one would work. They're the same thing. Okay. I want you to do something. So I know you can do, I'm going to have you do 1 through 8 all on page 479. 1 through 8 all. That is not what's on RenWeb. I want you to do page 479. Write that down right now. Page 479. 1 through 8 all. Got it? Okay.